Dear students, now we solve question number 38 from the question series of IIT JAM 2024 mathematics question paper. The question is, define f r to r and g r to r as follows. F of x is equal to summation m equal to 0 to infinity minus 1 whole to the power m x to the power 2m by 2 to the power 2m into m factorial whole square, and gx is equal to x by 2 summation m equal to 0 to infinity minus 1 whole to the power m into x to the power 2m by 2 to the power 2m into m plus 1 factorial into m factorial for x belongs to R. Let x1, x2, x3 and x4 belongs to R be such that 0 less than x1 less than x2, 0 less than x3 less than x4. F of x1 is equal to f of x2 is equal to 0, and f of x not equal to 0 when x1 less than x less than x2. G of x3 is equal to g of x4 is equal to 0, and g of x not equal to 0 when x3 less than x less than x4. Then which of the following statements is or are true? The function f does not vanish anywhere in the interval x3 x4. Option B, the function f vanishes exactly once in the interval x3 x4. Option C, the function g does not vanish anywhere in the interval x1 x2. And option D, the function g vanishes exactly once in the interval x1 x2. So the question number 38, this is the question of section B. So here one or more than one option are true. Now let us try to solve this question. Here the given functions f and g are the sum function of the given power series. F of x is equal to summation m equal to 0 to infinity minus 1 whole to the power m x to the power 2m by 2 to the power 2m into m factorial whole square, and the sum function gx is equal to x by 2 summation m equal to 0 to infinity minus 1 whole to the power m x to the power 2m by 2 to the power 2m into m plus 1 factorial into m factorial. Now first we find the radius of convergence of the two power series. So here for the function f of x, let am is equal to minus 1 whole to the power m by 2 to the power 2m into m factorial whole square. So modulus am plus 1 by am is equal to modulus means this is positive, so 2 to the power 2m into m factorial whole square by 2 to the power 2 into m plus 1 means 2m plus 2 means 2 square into m plus 1 factorial whole square. This is equal to 2 to the power 2m, 2 to the power 2m cancel, 1 by 4 into m factorial by m plus 1 factorial whole square. This is equal to 1 by 4 into m factorial into m plus 1 factorial means m plus 1, so 1 by m plus 1 whole square. Now limit m tends to infinity, m plus 1 by am is equal to limit m tends to infinity 1 by 4 into 1 by m plus 1 whole square means tends to 0. Therefore, the radius of convergence is equal to infinity. Similarly, for the power series, here let Bm is equal to minus 1 whole to the power m by 2 to the power 2m into m plus 1 factorial into m factorial. So modulus of bm plus 1 by bm is equal to, here also it is positive, so 2 to the power 2m into m plus 1 factorial into m factorial by 2 to the power 2m plus 2, 2 to the power 2m into 2 square, it is into m plus 2 factorial into m plus 1 factorial. This is equal to 2 to the power 2m, 2 to the power 2m cancel, so 1 by 2 square means 1 by 4, m plus 1 factorial, m plus 1 factorial cancel, m factorial into m factorial by m plus 2 factorial means m plus 1 into m plus 2. So 1 by 4 into 1 by m plus 1 into m plus 2. Therefore, limit m tends to infinity bm plus 1 by bm is equal to limit m tends to infinity 1 by 4 into 1 by m plus 1 m plus 2 tends to 0. So the radius of convergence of the power series, this also infinity. Therefore r is equal to infinity. So both the power series has radius of convergence infinity. Now f of x is equal to summation m equal to 0 to infinity minus 1 whole to the power m into x to the power 2m by 2 to the power 2m into m factorial whole square, and gx is equal to x by 2 summation m equal to 0 to infinity minus 1 whole to the power m by 2 to the power 2m into m plus 1 factorial into m factorial. This is equal to x by 2 summation m equal to 0 to infinity into x to the power 2m minus 1 whole to the power m by 2 to the power 2m into m plus 1 factorial into m factorial means m plus 1 factorial means m factorial into m plus 1. So m factorial into m factorial means m factorial whole square into m plus 1 into x to the power 2m. Now if we multiply this by this is equal to, we get m equal to 0 to infinity minus 1 whole to the power m by 2 to the power 2m into m factorial whole square into m plus 1 into x to the power 2m into x means x to the power 2m plus 1. Now we multiply both sides by x. So we get x g of x is equal to summation m equal to 0 to infinity half into minus 1 whole to the power m by 2 to the power 2m into m factorial whole square into m plus 1 into x to the power 2m plus 2. Now we differentiate both sides because gx is the sum function of a power series and we can differentiate term by term of a power series within its interval of convergence. So d by dx of x gx is equal to summation m equal to 0 to infinity half minus 1 whole to the power m into 2m plus 2 into x to the power 2m plus 1. So 2m plus 2 means 2 into m plus 1 into x to the power 2m plus 1 by 2 to the power 2m into m factorial whole square into m plus 1. m plus 1 m plus 1 2 cancel. So we get summation m equal to 0 to infinity minus 1 whole to the power m by 2 to the power 2m into m factorial whole square into x to the power 2m plus 1. And from here if we multiply both sides by x we get x f of x is equal to summation m equal to 0 to infinity minus 1 whole to the power m by 2 to the power 2m into m factorial whole square into x to the power 2m plus 1. So we see that this power series and this power series is same. Therefore d by dx d by dx into x gx is equal to x f of x. Let h of x is equal to x gx and phi x is equal to x f x. Then d by dx of hx means h dash x is equal to x f x means phi of x. Since gx is continuous and differential within its interval of convergence and therefore gx is continuous and it is differentiate gx is continuous on x3 x4 and differentiate on x3 x4. Therefore gx is continuous and differentiable on x3 x4. Therefore hx is equal to x, gx is also continuous and differentiable. Continuous and differentiable on x3 x4 and x3 x4. Therefore and h of x3 is equal to x3 into g of x3 equal to 0, because it is given that g of x3 equal to 0. From here g of x3 and g of x4 equal to 0. Therefore h of x3 is equal to 0 and h of x4 is equal to x4 into g of x4 is equal to 0. hx is continuous on x3 x4 and differentiable on x3 x4, and h of x3 is equal to 0 is equal to h of x4. By Rolle's theorem, there exists at least one C belongs to x3 x4 such that h dash C is equal to 0, and from here we see that h dash x equal to phi x. Therefore h dash C equal to 0 means phi C equal to 0. Again phi C equal to phi of x equal to x f x. Therefore C f of C is equal to 0. Since C not equal to 0, so f of C is equal to 0. Therefore in the interval x3 x4 there exists a point C taking C equal to x1 or x2. That is, if we take here x1, then obviously x2 here, or if we take x2 here, then we get x1 here. Therefore we see that in the interval x3 x4 there exists x1 where f of x is 0. Since in the interval x3 x4 g does not vanish anywhere between x3 and x4, therefore x1 is exactly 1. Again in the interval x1 x2 or x1 x2 there exists a point x4 where g is 0. Therefore we see that option B, the function f vanishes exactly once in the interval x3 x4, and the function g vanishes exactly once in the interval x1 x2. Therefore option B and option D are true. Thank you.